Let's talk about a piece of technology that is so common, so everyday, we barely even notice it anymore. And yet, it's basically pure magic. Yep, we're diving into how Bluetooth actually works.
I mean, have you ever really stopped to think about it? How does your favorite song, or a podcast, or a phone call, how does it just leap through the air from your phone to your headphones? Perfectly. Without any wires.
Because what's happening here is kind of wild. Just to listen to some decent quality music, your phone is beaming about 1,000,000 ones and zeros. That's 1,000,000 bits of data over to your headphones every single second. How on earth is that even possible?
So let's start right there with that million-bit question. To really get our heads around how Bluetooth pulls this off, we first have to appreciate just how big of a challenge this really is. Okay, so the answer starts with a really simple idea that's behind all wireless communication. It's basically the idea of speaking with waves. Think about a simple traffic light. It uses different colors, right? Green and red. Those are just different wavelengths of light that our eyes can see. And they send a really simple message. Green means go, red means stop. Well, Bluetooth does the exact same thing, just with invisible radio waves. It uses one very specific wavelength, one invisible color, to mean a 1, and a slightly different one to mean a 0. And by flipping between those two super fast, it can send that huge stream of data.
Okay, but wait. That brings up a huge problem, doesn't it? If you're in a coffee shop or an airport, there could be dozens of people's phones and headphones all trying to talk at once. How does it not just become a giant, chaotic mess of signals?
Well, the first part of the solution is that Bluetooth gets its own private little neighborhood on the radio wave spectrum. It's a reserved slice, so it's not trying to shout over your car radio or TV signals.
And inside that little neighborhood is not just one big road. The engineers who designed this were smart. They split that Bluetooth band into 79 separate little lanes, or channels. That helps spread everybody out, which is a pretty good start.
So, having 79 channels helps. But how does your phone's signal find your specific headphones, and not the pair on the person sitting next to you? Well, for that you have to stop thinking of it as a continuous stream, and start thinking of it more like digital mail. And this is just brilliant. See, your song isn't sent as one long shout. It's chopped up into these tiny little envelopes called packets. Each packet has an access code, which is like the specific mailing address for your headphones. Then it has a header, which is like writing on the outside of the package saying what's inside. And finally, you get the payload. That's the good stuff, the actual little piece of your song.
All right, so we've got channels to keep things separated, and we've got packets to make sure the right message gets to the right person. But now we get to the most clever, the most elegant part of this whole system. This is the real secret sauce that makes Bluetooth so reliable.
Here's the truly mind-bending part. Your phone and your headphones don't just pick one of those 79 channels and stay there. Not even close. They are constantly jumping from one channel to another in a prearranged, secret, synchronized dance. The super technical name for this is frequency hopping spread spectrum.
And the speed of this dance is it's staggering. Your devices jump to a completely new channel 1,600 times every single second. A packet is sent, then they hop. Another packet, another hop. This constant, frantic movement is the key to everything.
Now you might be thinking, hold on a minute. I'm pretty sure my microwave oven uses that same 2.4 gigahertz frequency. And you'd be right. So, isn't that a problem?
Well, let's go back to our light analogy. A giant stadium floodlight and your phone screen both produce visible light, but you wouldn't stare into the floodlight from a foot away, would you? Your phone screen is totally fine. It's all about the power level. Bluetooth is extremely low power. Your microwave, on the other hand, is, well, it's designed to cook things with a ton of power.
So this is why that 1,600 hops per second dance is just genius. If one channel gets a little noisy, say because your microwave is running, who cares? Your devices are only on that channel for a tiny fraction of a second before they've already hopped to a clear one. This also makes it incredibly secure. I mean, good luck trying to eavesdrop on a signal that's changing its frequency 1,600 times a second. And if a single packet gets lost in the noise, no big deal. The system knows and just resends it on one of the next hops.
And what we've talked about so far is really just scratching the surface. So let's take a quick peek at some of the even deeper magic that makes this whole thing possible.
Remember how we said it uses one invisible color for a 1 and a different one for a 0? Well, if you want to sound smart at a party, the technical name for that is frequency shift keying. It's the basic language these devices are speaking. And to get data to move even faster, it can use even more complex tricks. For example, instead of just changing the frequency, it can actually change a property of the radio wave called its phase. It's basically a way to cram even more ones and zeros into the same signal.
You know, our source material from the fantastic channel Branch Education really puts it best. It might seem crazy or mind-blowing, but hey, it happens. That really does sum up the feeling you get when you think about all the complexity and pure genius packed into these tiny little devices, doesn't it?
So yeah, millions of bits chopped into tiny addressed packets, hopping across 79 channels 1,600 times a second, all just so you can listen to a song without a wire. It's an amazing reminder that our modern world is absolutely powered by invisible forces and just incredible engineering. Which kind of leaves you with one last thought. What other invisible technologies are making your world work right now?